There is a machine that can walk up a flight of stairs, fold a towel, and carry a 40-pound box across a concrete factory floor. For the last 15 years, the West treated this machine like a science fair project, a flex for tech billionaires, a billion-dollar lab toy designed to do backflips on YouTube. And then, in the first 6 months of this year, a single statistic quietly broke the global robotics industry. A single country shipped 97% of every humanoid robot on planet Earth. 97%. Think about that for a second. That is not a metaphor. That is just the math. If you see 100 humanoid robots working in warehouses, factories, and logistics hubs around the world today, 97 of them were built in China. The country that the global consensus said was years behind in advanced robotics just completely swallowed the market. This is happening right now, today, in 2026. And it is not happening because China built a better robot. It is happening because they stopped treating it like a robot and started treating it like something else entirely. If you want to understand how the global labor force is being rewired from the ground up, and why the most important manufacturing shift of the century just happened while nobody was looking, hit subscribe. It genuinely helps this channel bring you more deep dives like this one. Let's get into it. To understand why this 97% number is so staggering, you have to understand the machine that the rest of the world spent the last 2 decades trying to build. And to be fair to the incumbents, the machines they built are engineering marvels. If you have ever watched a Boston Dynamics Atlas robot do a parkour run, or a Tesla Optimus prototype sort battery cells, you have watched the absolute bleeding edge of control theory and mechanical engineering. These machines are incredible. They use thousands of sensors to maintain balance on uneven terrain. They can recover from being shoved. They are, by any traditional metric, masterpieces. But here is the hidden cost that the robotics industry has been ignoring for 15 years. They built these machines like aerospace projects. When you build a robot like an aerospace project, you use custom-machined aerospace-grade aluminum. You use bespoke hand-wound electric motors. You use proprietary hydraulic pumps or ultra-high-tolerance gearboxes. And you assemble them by hand, in a clean room, by a team of PhDs. The result? A machine that costs anywhere from $150,000 to over $2 million per unit. Now, do the math on global labor. There are roughly 800 million manufacturing and logistics workers on Earth. If you want to replace even 1% of them with humanoid robots to solve labor shortages, you need 8 million machines. You cannot build 8 million machines when each one requires a team of engineers and costs as much as a Ferrari. The old problem was not that the robots could not walk. The old problem was that the robots were economically useless. They were trapped in the aerospace trap. They were too perfect, too fragile, and far too expensive to ever do the one thing they were supposedly designed to do: replace human labor at scale. This felt like a problem with no real solution. The physics of walking is hard. The physics of walking cheaply was considered impossible. The industry consensus was that humanoid robots would remain niche research tools for another 20 years, until a group of engineers in Shenzhen decided to stop looking at the robot and start looking at the supply chain. So here is the question everyone in the industry should have asked. If the cost is the bottleneck, why did nobody just mass manufacture the parts? Why did it take until 2026 for someone to build a cheap humanoid? The answer is that the Western robotics establishment fundamentally misunderstood what the hard part of the problem was. For decades, the hardest part of building a walking robot was the balance algorithm, the control theory, making sure the machine does not fall over when it lifts one leg. Because the software was so impossibly difficult, the hardware was treated as an afterthought. You built whatever expensive, low-volume, custom hardware you needed just to get the software to run. This led to what the industry quietly called the actuator trap. Let me explain the physics. A humanoid robot has roughly 30 to 40 major joints: shoulders, elbows, wrists, hips, knees, ankles. Every single one of those joints requires an actuator, a combination of an electric motor and a gearbox that turns electrical energy into physical torque. But you cannot just use a standard motor. A human arm is incredibly strong but very compact. To replicate that in a robot, you need a harmonic drive, a highly specialized precision gearbox that can multiply torque by a factor of 100 without adding bulk. Historically, these harmonic drives were made by a handful of specialized companies in Japan and Germany. They were machined to microscopic tolerances. They cost anywhere from $5,000 to $20,000 each. Do the math. 30 joints, $20,000 a joint. That is $600,000 just for the motors and gears, before you even add the brain, the battery, the skin, or the software. The incumbents were trapped by their own supply chain. They were buying boutique parts for boutique machines. And because the volumes were so low, the suppliers had no incentive to lower the price. It was a death spiral of low volume and high cost, the dismissive nickname for the underdog approach, using cheap, mass-produced parts, was toy-grade robotics. The serious engineers in Boston and Silicon Valley believed that if you used cheap parts, the backlash in the gears would make the robot shake, the sensors would drift, the machine would be useless for precision work. That assumption held for a decade. The West optimized for the perfect backflip, and while they were looking up at the acrobatics, China was looking down at the factory floor. Here is the twist, and this is the part that changes everything about how we think about hardware. China did not solve the robotics problem by building a better robotics company. They solved it by realizing that a humanoid robot is not a robot at all. It is an electric vehicle that stood up. Think about that reframe for a second. By 2025, China was producing over 60% of the world's electric vehicles. And in doing so, they had built the most advanced, hyper-scaled, ruthlessly cheap supply chain for electromechanical parts in human history. Let's walk through the mechanism, step by physical step, to see how they hijacked the EV supply chain to build a humanoid. Step 1. The actuator. Remember those $20,000 harmonic drives? China's EV industry already uses millions of high-torque electric motors and precision reduction gears every single year. Where? In electric power steering racks, in active suspension systems, in automated tailgates. The Chinese supply chain had already driven the cost of high-torque, compact electromechanical actuators down from $20,000 to under $300. Companies like Unitree and Agibot simply took the exact same supply chain used to steer a 2-ton electric SUV, scaled it down, and put it in the elbow of a robot. Step 2. The eyes. A humanoid needs to see the world to navigate it. It needs cameras, depth sensors, and LiDAR. 10 years ago, a single LiDAR unit cost $70,000. Today, because of the autonomous driving boom in China, companies like Heisai and RoboSense are mass-producing solid-state LiDAR and vision modules for under $300 a pop. The robot's eyes are literally the same eyes used by a robot axi in Wuhan. Step 3. The chassis. Instead of CNC machining every bone out of aerospace aluminum, Chinese engineers switched to injection-molded, high-strength engineering polymers and carbon fiber composites, the exact same materials and manufacturing processes used to make the interior dashboards and structural components of millions of consumer electronics and cars. And here is the brilliant part: the old weaknesses of cheap robotics, the gear backlash, the sensor drift, the fragility, they do not get fixed by making the hardware better. They disappear because the software got smart enough to compensate for them. When your hardware costs $600,000, it has to be physically perfect. When your hardware costs $5,000, you just use a neural network to map the imperfections and correct them in software in real time. By treating the robot as an EV, companies like Unitree released the G1 humanoid for $16,000. $16,000 for a bipedal machine with 40 degrees of freedom. That is not a typo. That is the price of a used Honda Civic. The substrate changed. The aerospace trap was broken. And the moment the price dropped below the cost of a year's salary for a human factory worker, the floodgates opened. But a cheap robot in a catalog is one thing. A robot that actually works on a real assembly line is another. And this is where the story shifts from clever supply chain hack to industrial reality. Because these machines are not sitting in labs, they are on the floor, right now. Take UBTECH Robotics, based in Shenzhen. Their Walker S humanoid is not doing backflips for YouTube. It is currently deployed inside the manufacturing plants of NIO and Afei Dui, two of the largest automakers in China. Watch the footage from the NIO plant. The Walker S walks up to a car chassis on the assembly line. It uses its vision system to locate the seatbelt anchor point. It reaches out with a torque wrench attached to its wrist. It tightens the bolt. And then, and this is the critical part, it reads the digital torque feedback to verify that the bolt is tightened to the exact safety specification required by the factory. It logs the data, and it moves to the next car. It is doing repetitive, quality assurance, physical labor, the exact labor that causes repetitive strain injuries in humans. The exact labor that is incredibly difficult to hire for in an aging society. And it is not just one pilot program. According to the industry data released just this week, Chinese companies supplied over 97% of all humanoid robots shipped globally in the first half of 2026. Let's zoom out to the national policy layer, because this is not an accident. This is a state-directed industrial strategy. China's Ministry of Industry and Information Technology, MIT, released a formal blueprint for the humanoid robotics sector. The targets are concrete and staggering. They mandated mass production and commercial deployment by 2025, and they are targeting absolute global dominance and deep integration into the national manufacturing base by 2027. To achieve this, the state is pouring billions of yuan into the sector. Local governments in Shenzhen, Shanghai, and Beijing are offering massive subsidies, cheap factory space, and guaranteed procurement contracts to companies like Fourier Intelligence, UBTECH, and Unitree. Fourier's GR1 robot is already being deployed in healthcare and logistics, capable of carrying heavy loads and assisting with patient movement. UBTECH is scaling production to thousands of units a year. Every month, the cost drops. Every quarter, the deployment scales. The 97% market share is not a temporary anomaly caused by a single large order. It is the mathematical result of a country that controls the entire supply chain, from the raw neodymium magnets in the motors to the final assembly line, flooding the zone with volume. They took the most complex mechanical system ever designed, and they turned it into a consumer electronic. But here is the honest part of this story. And I want to be straight with you, because this format does not do blind hype. China has won the hardware war. They own the physical machine, but they have not yet solved the ghost inside the machine. And this is where we run into a very specific, very real limitation known in computer science as Moravec's paradox, combined with the sim-to-real gap. Moravec's paradox is the observation that high-level reasoning requires very little computation, but low-level sensory motor skills require enormous computational resources. It is easy to make an AI pass the bar exam. It is incredibly hard to make an AI fold a fitted sheet. Right now, the Chinese humanoids deployed in the NIO factories are brilliant, but they are highly specialized. They are trained to do one specific task, in one specific lighting condition, on one specific car model. If you move that exact same robot to a chaotic, unstructured environment, say a commercial kitchen, or a messy warehouse where boxes are thrown randomly on the floor, the robot will freeze. It lacks the embodied AI foundation models required for zero-shot generalization. It cannot improvise. The absolute bleeding edge of spatial reasoning and generalized physical AI models is still heavily concentrated in the United States, driven by companies leveraging massive simulation-to-reality, sim-to-real training clusters. The US is still trying to build the brain that can handle infinite edge cases. Furthermore, there is the hardware reality of battery density. A current Chinese humanoid can operate for roughly 2 to 4 hours before it needs a battery swap or a recharge. In a 24-hour factory cycle, that means you need 3 robots to cover 1 human shift. None of this erases what the supply chain has already proven. It simply marks the distance between a cheap, capable body and a truly autonomous mind. China has commoditized the muscle. The race for the brain is still underway, but as any manufacturing executive will tell you, once the hardware is cheap enough, the software always catches up. Which brings us back to the bigger picture this whole story has been building toward. Because this is not really about robots. It is about demographics. And it is about the industrialization of physical labor. For the last 40 years, the global economy has been built on a specific geographic division of labor. The West designed the products, and the East assembled them, leveraging a massive, young, cheap human workforce. But that demographic dividend is over. China's population is shrinking. Its workforce is aging. The era of cheap, infinite human labor in the Pearl River Delta is mathematically finished. The West assumed this demographic collapse would naturally weaken China's manufacturing dominance. They assumed the factories would move to India, or Vietnam, or Mexico, chasing the next generation of cheap human hands. They were wrong. China did not accept the demographic decline. They engineered a workaround. By hijacking the EV supply chain and driving the cost of a humanoid robot down to $16,000, they are actively replacing their retiring human workforce with an immortal, tireless, mechanical one. The world that ran on cheap human labor didn't announce its own ending. It just started losing ground to something that doesn't need sleep, doesn't need a pension, and doesn't care about the demographic cliff. We have seen this movie before. China did the exact same thing to the solar panel industry. They did it to the commercial drone industry. They did it to the electric vehicle industry. They take a boutique, high-margin Western invention, apply the brute force of their supply chain, and turn it into a cheap, ubiquitous global infrastructure. Now, they are doing it to the physical workforce. So here is the question I want to leave you with, and I genuinely want your answer in the comments. When the physical labor force of the future is manufactured in Shenzhen, powered by Chinese batteries, and maintained by Chinese software, who actually owns the means of production? The country that designs the product, or the country that builds the machines that build the product? Drop your answer below. I read every single one. And if you want a front row seat for the next time an impossible monopoly gets broken by sheer industrial scale, hit subscribe. The next decade of this story is going to move faster than anyone expects, and you are going to want to be here for it. I'll see you in the next one.